Woohoo! And welcome to 6.5 Loans and Amortization. And we're going to start off this section with a brand new word, amortize. Amortize comes from the word to kill, and it is literally a killing off a loan or repaying a loan with equal payments. And it would seem like that would not be a hard thing to do, but it's actually a pretty complicated situation to set up. And it's something that comes up for the most part when we're talking about loans that you take out on either houses or vehicles or land. And they're usually very large loans, and you're going to make equal payments either every week or every year or every month. And so we're going to do some pretty interesting math to figure out how to set up this process. If you have a loan on a vehicle, if you have a car loan, or if you're lucky enough to have a mortgage, and I don't know, some of you who might have a mortgage might say, well, lucky is not the word you'd think of. But if you do have a loan like that, what you probably have noticed is you pay the same amount every month. And that can be really helpful because it helps people to plan, it helps people to budget, it makes sure that you're not it takes out that uncertainty. And so that's why this is a very common way to structure a loan. So the first thing I'm going to point you to is that on pages 406 and 407 in the book, they actually go over setting up an amortization schedule. Since this is a part of the curriculum in the accounting department, I'm going to let them do it because they're going to be able to show you how to do it with a lot more real life experience. I'm coming at this having not worked in the banking world, so I can explain this all from the mathematical perspective, but I don't have the grounding that would be useful. So if you do have questions about the amortization schedule, I can absolutely help explain what it means. On the second page here, after this page, I'm going to set up a very, very short amortization schedule, but not in a fancy way, not in a formal way. And again, I'm going to allow accounting and finance and all of those classes to inform you better in things like what the banking policies are, how rounding works, because I know it from the mathematical perspective, but I don't really have as much information about what happens in the real world. What a surprise. Okay, so I'm going to set up a problem. I'm going to borrow $100 from my friend, and I am going to pay $20 back each week plus 10% interest each week. So my friend is apparently not a great friend, or it was hard to talk them into this loan, because 10% interest each week is 520% over the course of the loan in terms of simple interest. And who knows, what that would amount to with the compounding and all that fun stuff. So this is a very expensive loan, but 10% was just an easy way to do it. So that's how I set it up. So let's take a look. So the first method we're going to talk about is different payments each week. So this is not amortizing a loan. This is just paying back my friend. And I'm going to pay $20 plus whatever interest I've accrued. So let's look week by week. And I made a little note here that says, since I am calculating each week separately, I'm using simple interest in each week, right? So for each week in between the compounding periods, or in the middle of the compounding periods, I should say, we're using simple interest. So week one, at the very beginning, I owe $100. So I'm going to take $100 times 10% for this week. And again, we're making the math simpler. We're paying at the end of the week. So these are going to be ordinary annuities as opposed to paying at the beginning of the week. So for this week, I'm going to incur 10% interest. So $100 outstanding times 10% is $10. So I owe $10 in interest. I'm going to pay the $20 in principal, right? How much I'm actually paying back of the loan, plus the $10 interest, which means I've got a $30 payment. And then I still owe, even though I paid them $30, $10 of that was interest. So I owe 100 minus 20 equals 80. So that's how I'm going to set this up every single week. Okay, then I go in with $80. 10% of $80, because I only have an outstanding balance of $80. This week I owe $8 in interest. So as I pay off the loan, my interest payment is going down. So that's something to remember. That's actually really important for the rest of this chapter. So I owe $80 times 10%. That's $8 in interest. And then I'm also going to pay the $20 principal. I'm always going to pay $20 each week. So I owe $28 this week. So I owe slightly less, which is kind of nice. Pardon me again. Pardon me. I think I'm allergic to interest payments. I wonder if I can take Claritin for that. So I still owe 80 minus 20 is $60. So we're going to continue like this. Then I owe $60. So 60 times 10%. You can see why I picked 10% as our interest. It's really nice and easy. 10% of 60 is 6. So this week I owe $26. I pay off that $20 in principal. So I have 60 minus 20 is 40. Week 4, $40 outstanding. So I owe $4 in interest. So my payment will be 20 plus 4 is 24. And I pay it down to $20. And then week 5, that's my last week because I have $20 in outstanding principal. I owe $2 for that one. So 20 plus 2 is 22. And I've paid off the last of my principal. So my loan is paid off. Woohoo! If I look through all these different payments, the 30, the 28, the 26, the 24, and the 22. Here's the 30, the 28, the 26, 24, 22. Through the magic of television, I've added it together. I've paid a total of $130. And so I'm going to quickly slide over. And I know this is going to be really goofy, but let me just talk about what's at the top there. Next page. So my total interest paid was $130, right? That's the total of my payments is $130. I owed $100. So $100 of that went to pay off the principal for the loan. And so I ended up paying $30 in interest. And the question is there a way to set it up so my total payment stays the same each week? Why is this complicated? Well, it's complicated because as I pay off my principal, the interest that I owe decreases. So you have the interest actually changing week to week. Now, what you could do is you could just figure out pretty kind of an average of all those payments and then kind of split the payments up into multiple pieces. That is not, in fact, the way that historically we've done it. So let's take a look. Now, again, you're going to have, and here's Godzilla, because, I figured Godzilla would join us. I didn't explain this because Godzilla had to take out a loan to rebuild Tokyo a couple times, actually. Godzilla has promised to stop taking out her existential angst about the way that humans have been caring for the planet by destroying cities. She is currently seeking a mortgage to rebuild Tokyo. And so she's here to learn a little bit and make sure she understands the loan she's about to get into. So here, my method is, through the magic of television, I've come up with this magical number, and I'm not going to tell you yet how I get it, although you can probably guess there's going to be a formula. So I just say, hey, what if I paid $26.38? $26.38. I don't know why. I just picked that number either at random or because I'm the teacher and I know how the rest of this chapter is going to go. Who knows? So let's look again week to week. And again, if I look at each week, if I look at each compounding period separately, I can treat the interest in that week as simple interest. So let's take a look. Outstanding balance is $100. The interest due this week, again, I owe 10%, so I still owe that $10. That first week, isn't that different. I still owe $10. But I'm only paying $26.38. So what the heck does that mean? Well, that means at the end of this week, I owe $100. That's how much I owed from my loan, plus $10 in interest. So this is the principal. This is the interest. And that's my payment, $26.38. And so I paid it down to $83.62. That's how much is outstanding. And that's what I'm going to put here as my outstanding balance. Okay, next week. Now it gets really complicated. 10% of $83.62 is going to be $8.36. Now notice that due to rounding, this is going to get a little funky because it means that technically I owe $8.36 and 0.2 of a cent. But there's no way for me to pay that. So we're going to have rounding. So by the end, we're going to have some funky rounding error. We'll deal with it. So I owe $8.36 in interest. So that's my outstanding principal for the week, $83.62. And I add $8.36, the interest that we just calculated. And again, I make that same payment. And here I'll go with green in honor of our friend Godzilla, who's learning a lot every week, except for possibly the last week. Sometimes the last week it's a little funky. In this case, I picked an example where it isn't funky. It works out. So I'm going to pay $26.38. So I have this outstanding. I have the principal that I owed at the beginning of the week plus the interest incurred in that week. And then I make my payment, and now I still owe $65.60. Okay, so I go in $65.60 times 10%, $656, nice and even, yay. So I add my principal, my interest, and I make my identical payment, and I'm down to $45.78. Okay, then I get $45.78. And then 10% of that is 4, and then it gets a little funky again because since I have to round to the nearest cent, it goes to $4.58. Okay, so I owe $45.78 plus $4.58. I make my payment, and then I have an outstanding balance of $23.98. Now, at this point, a lot of people are like, wait, I could just pay that off. And the answer is, if your loan is structured in such a way that you can make early payments, then yes, you could totally pay this off at the beginning of the week and be done. But the way this loan is structured, we're going to go ahead, we're always going to pay at the end of the week. So $23.98 is outstanding. I owe 10% in interest, that's $2.40. If I take $23.98, add $2.40, subtract $26.38, I get $0 exactly. So by paying $26.38 every week at the end of the week for 5 weeks, I paid off my loan. Now, let's look at the total payments. The total payments actually come out to $131.90. My principal, my outstanding principal, was $100. So $131.90 minus $100 is $31.90. So in the first case, when I went ahead and just paid whatever interest was incurred that week, I paid $130. So in this case, I pay $131.90, so almost $2 more. And so let's look at the benefits versus the downside. The big benefit of amortization, pardon me again, I seem to really be allergic to owing people money. How about you, Godzilla? Yep, you're having trouble with it too? I know, it's, mortgages. There's a reason that it comes from the word that means to kill or death. Benefit of amortization. You pay the same amount each month, making it easier to budget and plan. You can sign a contract that very clearly says, and if you've got a loan, you've signed this contract, you will owe this much each month or each week or each year, which depending on your contract. The downside of amortization. In the beginning, more of your payment goes towards interest than towards principal, so it can feel frustrating when the loan amount doesn't change quickly. So the way we did it here, by the end of the first week, in the first case, I have paid off $20, so I have only $80 left that I owe. In this case, I didn't pay quite as much of the principal. I had a lower payment, but I paid less. And so I still have $83.62 outstanding in the first week. So amortization, is almost always going to leave you with a lot of high interest payments in the beginning. And then towards the end, you pay it off really quickly. It goes really fast in the last, third or quarter of the loan. But in the first 3/4 of the loan, it feels like you're going to owe money forever. How to hack your payments. Okay, this is not part of the class, nor is it part of the book or even part of the homework. But it's something that I think is really something that humans who might have a loan should know. So if the loan allows it, and if you can afford it, round up your payments to pay off extra principal each month. So, if your loan has something called a prepayment penalty, which means you can't pay ahead of time, or else they charge you more if you try to get rid of your loan early, then you can't do this. But for many car loans and almost all mortgages, you can actually try this. And I'm just going to show you. So what does it mean to round up? Well, instead of paying $26.38, we're going to go ahead and I'm going to run through all 5 weeks paying $27. Oh, and whoa, I don't know why that says that. What? Is that a pterodactyl behind you? What? You better look around. Don't look at the screen right now. Check to see if that's a pterodactyl. No? Okay. Yeah, I guess I was wrong. No, I don't know what I was thinking. I don't know what I saw. So let's look back here. Look, magically, it says the right thing. Round up your payments, pay $27 each week. So instead of $26.38, let's pay a little bit more. Let's see what that does. Now, why would I round up just a little? Maybe I could round up to 30. You could absolutely, if you can afford it, round up to 30. Heck, if you can afford it, pay the thing off right away. It all depends on how much you can afford. The more you pay in the beginning, the less you will pay over the life of your loan. But I'm just going to round up to the next dollar. So let's look at $27. So again, same work we've been doing now for 2 other examples. $100 owed, $10 in interest in the first week. So I've got that 100 plus the 10 minus 27. Now I'm down to 83. So I've paid a little bit extra. Okay, if I have $83 outstanding, 83 times 10% is $830. So I've got my $83, my interest for that week, $830. I pay my 27, and there's my new principal outstanding loan balance, $64.30. Okay, take $64.30. Again, 10%, $643. So I've got my principal, the interest for that week, and I make my payment of $27, and that leaves me with $43.73. Again, $43.73 times 10%, $437. $43.73 plus $437 minus 27 gives me $21.10 outstanding. Okay, one more time. $21.10 times 10% is $2.11. So I've got my principal, my interest, and notice I don't pay the $27 in my last payment because I've paid ahead. I've paid extra each week. I only pay $23.21. So this is a smaller payment. And let's look at the totals. If I pay 27, 27, 27, 27, and then that extra small one, the 23, 21, I paid out 131.21, and so my interest is 31.21. How does that compare? Well, over here, my total interest paid is 31.90 instead of 31.21. So in just bumping up my payment a little bit each week, my last payment is a lot better. It's a lot smaller. And I save 69 whole cents. And I know you're all celebrating going, woohoo, what are we going to do with 69 cents? And the answer is, well, this is an example over 5 weeks with a $27 payment. If you have a car payment or a mortgage, and you're talking about hundreds or thousands of dollars. If you imagine, if you can round up, if you can afford to round it up even to the next dollar, or if you can even afford to round up to the next $10, you will see that you will be able to pay off your loan a lot faster. And so definitely consider it. That's the hack. It's not in the book, it's not officially in the class, but it's something that, like, human beings who want to engage in finance should know about the world. Okay, so I know you're all asking, wow, we've gone through 3 examples. This has been amazing. I've learned so much, but please, please, please give us the formula. And I will say, you already had the formula. The formula was in your heart the whole time. What do I mean by that? Well, the present value of an ordinary annuity is given by this. You can take my word for it. I know at this point a lot of people's eyes are just glazed over. This is the formula that we found in 6.4. This is the present value of an ordinary annuity. Why is this the present value of an ordinary annuity? I'm going to go back here and I'm going to say this is an ordinary annuity. What are we doing? We're making regular payments, and in fact, we're making regular equal payments, right? One every week at the end of the week. That's an ordinary annuity. Okay, so a loan, when you pay it off, the bank has bought an annuity from you. They are investing in you. Literally, you are their investment, which is kind of a weird way to think about it. But this is part of how they make money. They actually take the money they have and they loan it to people, and then people pay them back the annuity so they can plan on this interest coming in. This is also why sometimes banks say you can't pay it off ahead of time, because they don't want you to pay less interest. So good thing to know. So this is our formula from 6.4. And all I'm going to do is I'm going to take this formula right there, right? I'm going to multiply on each side by this little blue guy, which is just this fraction flipped upside down. So do you see that? That's this fraction. And so these, get my red pen of destiny, the I cancels. This whole 1 minus 1 plus I, that quantity to the opposite of n, cancels. And all we have is R by itself. And then A is multiplied times the, a little bit ugly, not impossible. You get used to using it. This fraction, this rational expression. Okay, and we're going to call it the amortization formula, but you're going to say this is really just the present value of an ordinary annuity. It really is. We just took it and we kind of shook everything up. Sorry about that. Shake it up. And not singing. I know, I vowed never to sing again, so I'm going to let that slide. If you decide to sing right now, awesome. In fact, I should take a break and listen. Are you singing? There are a couple different songs you could be singing right now. Okay, that's lovely. Okay, the amortization formula for a debt of A, that's the present value. Why is it the present value? Well, because your mortgage money comes today, right? When you sign the contract, the bank gives you the money to give to the person who owns the house. The bank gives you the money to give to the person who owns the car. So you get it today. So it's present value. So that's the present value with an interest rate of, and then this is unfortunate. I'm going to draw a little I there. Sometimes Microsoft Word insists on capitalizing I's and I can't make it stop. I per period. Remember, that's R over M. Remember that? I'll make a little note here. I equals the interest rate over M. Remember that. Amortized by N equal periodic payments. And remember here that when we're talking about N, that's the number of years times the number of payments per year. So just remember that. So this is the same, these are the same things we've been talking about all through chapter 6. The size of each payment is given by, so now here is the regular payment. Here's the present value or the loan amount. the interest rate per period, 1 minus 1 plus the interest rate per period, all raised to the opposite of the total number of payments. And that's it. This is the magical formula which you can use to then calculate any loan payment you'd like. And I will say that I did once use this when I bought my very first car. I already knew this formula, and I bought a little tiny blue Tercel back in the 90s, the 1790s. And when we went in to get the loan, they told us what our monthly payment would be. And I did a quick calculation and realized that they were going to try to charge us like 30% interest. And I said no. And so we had a long conversation. And, to make a long story short, I got the car, I got a reasonable payment. Knowledge is power, and you guys are awesome and very powerful now. You know it. This is it. This is the foundation of all money lending in our country and the world. This is it. You now know how to calculate the payment for a loan. And you can also calculate things like you could figure out if you wanted to pay it off more quickly. Let's say you have a loan and it's going to last 7 years, but you want to know how much should I pay per month to make it only last 6 years or 5 years. You could go in and tweak that end, figure out what your new payment amount should be. You could go in, if you have a credit card an outstanding credit card balance, you could put that in. You could figure out what your interest rate is, which you should know what interest rate you're paying on your credit cards, just so you know what you're getting into. Figure out how long you're going to give yourself to pay it, and you can figure out how much you should be paying every week or every month to get that thing paid off. You're masters of the universe at this point. Woohoo. So, congratulations. You made it through a very long lecture. The very next one, we're actually going to go into a particular problem, and I'm going to show you how this formula works. I've also included a separate video with how to use your calculator, because again, this gets a little bit complicated on calculators. So I've gone ahead and recorded myself actually working through a problem using the calculator. And then, of course, you can always go into like Google Sheets or Excel and calculate payments there. And if you ever have questions about that, let me know and I can help you with that as well. And I'm sure you learned how to do that in accounting too. Woohoo! Yay accounting! Yay math! Yay loans! Yay capitalism! Am I right? Okay, woohoo! Go out and be awesome. And, you're amazing. You're incredible. Remember to hydrate, eat your vegetables, get a little bit of exercise, get some sleep, and math on.